Let's move away from talking about matter for a little bit and start talking about energy. Energy can be transmitted through space in the form of electromagnetic waves, and the amount of energy that these waves have determines the type of wave. Here is a picture of the electromagnetic spectrum with a list of all the different types of waves. So on the low energy side, we have radio waves. So these waves are what carry what we normally think of radio. Maybe you're listening to the car, and these waves are very low energy. They have a very long wavelength. Waves that have a slightly higher amount of energy are microwaves. Microwaves, as can be told from the name, are what are used in microwave ovens to heat up food. They have a little bit more energy than the waves that form radio waves. If we keep going higher in energy, we get infrared waves, and these waves have a slightly shorter wavelength and usually are associated with carrying heat. So heat lamps tend to give off infrared radiation. A little bit higher energy, we have the visible spectrum of waves, and as can be seen in this diagram of the electromagnetic spectrum, these waves are a very narrow range out of the entire electromagnetic spectrum, but these are the waves that we can detect using our eyes. The reason why we can't see the lower energy and the higher energy waves around the visible spectrum is our eyes, the molecules in our eyes, are not sensitive to those energies of waves. Now, if we look at what has higher energy than visible light, ultraviolet, UV light. This is the light that we think about when we're thinking about sunburns. Ultraviolet light from the sun gets through the atmosphere, hits our skin, and causes DNA damage. Higher energy, again, this part of the spectrum is known as ionizing radiation because it has the energy to destroy or change molecules. But we have X-rays, and X-ray radiation with this short wavelength is used when you go to the doctor and get an X-ray to look at bones. These waves have the energy to pass through the skin. And then finally we have the highest energy type of wave, and these are known as gamma rays. These are often given off by things such as supernova. They are very, very high in energy, but fortunately most of these waves are deflected by the magnetic field that surrounds the Earth. And just to reinforce the idea, this end of the spectrum, the radio wave, is low in energy, and this end is high in energy. So now that we've talked a little bit about the electromagnetic spectrum and types of waves, let's look at the properties of a wave itself. The top of the wave up here is known as the peak. So every time the wave reaches its maximum, that will be the peak. The bottom of the wave down here is known as the trough. If we measure the distance between the peaks, this is known as the wavelength. And is usually denoted by the symbol Greek letter lambda. If we measure the distance between the middle of the wave and the peak, we get the amplitude. The last term we need to know is frequency. The frequency is how many peaks, because this wave is going to be moving one way or the other, how many of these peaks pass by one point every second. So let's formally define these terms. So we have the peak of the wave, and this will be the highest point on the wave. We have the trough. This is the lowest point on the wave. We have the wavelength, and the wavelength is the distance between two peaks of the wave. And the wavelength determines the type of wave. Or if we're dealing with the visible spectrum, color. We also defined amplitude. The amplitude of the wave is the height of the wave peak from the center of the wave. What does this relate with when we're talking about waves? Well, this will be the brightness of the wave. The higher the amplitude, the brighter the light, or the louder the noise if we're talking about a sound wave. And last, we have frequency. Frequency is the number of wave peaks that pass a given point every second. And how are these things measured? Well, the wavelength tends to be measured in meters or nanometers. And the symbol again for wavelength is the Greek letter lambda. Frequency is measured in the unit of 1/seconds, which is the same as s to the -1, or also known as hertz, Hz. The symbol for frequency is the Greek letter nu. And frequency tells us the energy of the wave. The higher the frequency, the higher the energy. So radio waves have a much lower frequency than gamma rays, because gamma rays are much higher in energy.